What is the difference between an atom and a molecule? So take a look at these three substances: helium, hydrogen gas, and H2O. Which of these substances are composed of atoms and which ones are composed of molecules? Helium is composed of atoms. Each particle of helium is made up of one atom of helium. A particle of hydrogen gas is a molecule. One particle contains two atoms. A molecule is basically a particle with multiple atoms. Water is a molecule. You have an oxygen atom and two hydrogen atoms. So at the center, this is the larger oxygen atom, and then these are the two hydrogen atoms. So a molecule is basically a particle with many atoms. It could be made up of the same type of atom or different types of atoms. Helium is considered to be a pure element. It's made up of only one type of atom. Hydrogen gas is also a pure element. Water is not a pure element because water has two different types of hydrogen atoms. Just atoms in general. It's composed of hydrogen and oxygen atoms. So water is not a pure element. But H2 and H2O are considered to be molecules. So let's work on some more examples. For each of these substances, determine if it's composed of atoms or molecules, and also determine if it's a pure element or if it's a compound. Let's start with O2. Is it composed of atoms or molecules? One particle of O2 contains two atoms, so it's a molecule since it contains multiple atoms. Now, because it only contains one type of atom, it's a pure element. The only type of atom that we have in O2 are oxygen atoms. Now, what about CO2? Would you consider a particle of CO2 as an atom or a molecule? Now, CO2 contains many atoms, so it's considered to be a molecule. However, it doesn't have one type of atom. It's composed of different types of atoms. It has carbon atoms and oxygen atoms, so therefore it's not a pure element. It's a compound. A compound is a substance that is composed of many different types of atoms. A compound is basically not a pure element. Neon is composed of atoms. One particle of neon looks like this. It's simply one atom. Whereas an oxygen molecule, is composed of two oxygen atoms. So that's why O2 is a molecule and neon is not. And let's say if we wanted to draw CO2, there are three atoms. We have a carbon atom and two oxygen atoms. So this is the carbon, and these are the two oxygen atoms. Neon is also a pure element because we don't have two different elements. There's only just one neon. Now what about fluorine? Fluorine is very similar to O2. It's composed of molecules because each particle contains multiple atoms, and it's a pure element. We only have one type of atom. So now you know the difference between atoms, molecules, compounds, and pure elements. So just to review, a particle is considered an atom if there's only just one atom. If there's multiple atoms, then the particle is considered to be a molecule. If there's only one type of atom, it's a pure element. And if there's different types of atoms, you have a compound. Now, what is the difference between an atom and an ion. What do you think the difference between these two are? Atoms are electrically neutral. Atoms contain an equal number of protons and electrons. Ions, on the other hand, contain different number of protons and electrons. So a good example is the aluminum atom and the aluminum ion, which has a 3+ charge. Aluminum has an atomic number of 13 and a mass number of 27. On a periodic table, the smaller number of the two numbers that you'll see is the atomic number. The atomic number is always equal to the number of protons. So aluminum has 13 protons. The aluminum ion also has 13 protons. The difference between the mass number and the atomic number is the number of neutrons. So aluminum and the aluminum ion contain 14 neutrons. Now the electrons are different. In an atom, which is electrically neutral, the number of electrons is going to be the same as the number of protons. To calculate the number of electrons, you can use this formula. It's equal to the atomic number minus the charge. So in the case of the aluminum atom, it's 13 minus a charge of 0, so that's where we got 13. Now, in the case of the aluminum ion, it's going to be the atomic number of 13 minus the positive 3 charge, so there's 10 electrons. And it makes sense. Each proton has a charge of 1, so there's 13 protons. That's the net charge of plus 13 in the nucleus. Each electron has a charge of minus 1. There's 10 of them. If we add these numbers, this will give us a net charge of positive 3. Ions that have positive charges are known as cations. Ions with negative charges are anions. So let's say if we have phosphorus 31 and the phosphorus 31 ion, which has a -3 charge. So this is called an anion, since it has a negative charge. Now, both of these particles have 15 protons. 31 minus 15 is 16, so they both contain 16 neutrons. But atoms and ions, they differ in the number of electrons that they have. On the left, because we have an atom, it's electrically neutral, so the number of protons and electrons are the same. In the case of the anion, it's going to be the atomic number minus the charge. So the atomic number is 15 minus a charge of -3. This will give us 18 electrons. 15 minus -3 is the same as 15 plus 3. So whenever you have a negatively charged ion, it means that there's more electrons than protons. And when you have a positively charged ion, there are more protons than electrons. Now let's focus on compounds, because there's two types of compounds that you need to be familiar with: ionic compounds and covalent compounds. So let's look at sodium chloride and H2O. Sodium chloride is basically table salt. H2O, as you know, is water. Both of these are compounds because they're both made up of different types of atoms. Sodium is one type of atom, Cl, chlorine, is another type of atom. Now, which compound is ionic and which one is covalent or molecular? Covalent compounds are known as molecular compounds. A quick way to tell is ionic compounds are composed of metals and nonmetals 99% of the time. Covalent compounds are usually composed of nonmetals. Sodium is a metal. On a periodic table, sodium is all the way on the left side. The left side contains the metals, the upper right corner contains the nonmetals. Chlorine is a nonmetal. It doesn't conduct electricity. Hydrogen and water are both nonmetals. Even though hydrogen is in the upper left corner, it's not considered to be a metal like sodium or lithium. So water is considered to be a molecular compound or a covalent compound because it's composed of nonmetals. In a molecular compound, the electrons are shared between the atoms. So hydrogen and oxygen, they share electrons. In an ionic compound, like NaCl, the electrons are not shared. There's a transfer of electrons. Sodium gives one of its electrons to chlorine, and thus it turns into a sodium cation, and the chlorine becomes an anion. So ionic compounds are composed of positive and negative charges. That's another way to tell. And molecular compounds are not composed of full charges as you see here. So that's a quick and simple way to determine which one is ionic and which one's covalent. So let me give you some more examples. Carbon monoxide, magnesium chloride, sulfur hexafluoride, and let's use calcium oxide. So carbon monoxide, is it a molecular compound or is it ionic? This compound is molecular or covalent because carbon and oxygen are both nonmetals. Magnesium chloride is ionic because magnesium is a metal, chlorine is a nonmetal. Here we have two nonmetals. I'm going to use N for nonmetals and M for a metal. Sulfur hexafluoride, that's composed of two nonmetals. Sulfur and fluorine are both nonmetals. So this is going to be a molecular or a covalent compound. Calcium oxide is ionic. Calcium, like magnesium, is an alkali earth metal. It's in the second group of the periodic table, that is the second column. It's composed of a metal and a nonmetal, making it ionic. Now there is an exception. Ammonium chloride. Nitrogen is a nonmetal. Hydrogen is also a nonmetal, and the same is true for chlorine. So there are no metals in this compound. So you might think that this is a molecular compound, but you need to be careful because it's composed of ions. Ammonium contains a net positive charge, and the chloride ion contains a negative charge. So because this is composed of ions, it's considered to be ionic. So watch out for exceptions. So anytime you see NH4, just know that it has a positive charge. So chances are it's an ionic compound and not a molecular compound. But for the most part, if you see a compound composed of a metal and a nonmetal, it's typically ionic. And two nonmetals are usually molecular compounds or covalent compounds. That's just a general rule. But as you can see, there are some exceptions.